So we have most of our cost curves in here. We're generally not going to have just the total cost curves that go up. We're usually going to look at the average total, average variable, and average fixed cost curve with one more curve in here, because that's going to tell us almost all of what we're going to want to know about what the best production decisions are going to be. And like I said in the last video, this is going to be revisited a lot. It's a very, very important graph. It's going to be really the rest of the semester. Every market we're going to look at, we're going to come back to this graph and look and see what all of these things look like, along with the other things we're going to put in. And those other things we're going to put in are going to be marginal cost curves and marginal revenue curves, and those are going to drive so much of the decision making we're going to make at the firm level about quantities and pricing. That's getting ahead of ourselves a little bit, but it's important just to foreshadow a little bit there to make sure that you understand that you should know this graph. You will be tested on seeing if you're not going to be given the labels here, but you're going to be given the curves, and you're going to need to know, based on their shape and based on their position relative to the other curves, which curve is which, along with the other curves we're going to put in there. So get to know these really well, and make sure that you know that the curve that goes down for a bit and then goes right back up, bowl-shaped sometimes it's referred to. It's also called U-shaped sometimes, even though it's not a perfect U. The one on top is going to be the average total cost curve. The one beneath it that does the same thing, it declines for a bit and then it goes back up and has a nice smooth U look to it, but it's underneath the average total cost curve at all times. That's the average variable cost curve. And the one that just keeps going down and down and down forever is the average variable cost curve. You're going to need to know those, and you're going to need to know about marginal costs. So to understand the marginal cost curve, let's get into what marginal costs are. We've already covered margins a little bit, and it basically takes wherever you are in the production process. If you're deciding between not making anything or making just one unit, or deciding between making 0 units or 10, and you have to decide between the two because sometimes making things in bundles is more efficient. Or perhaps you've already made 1,000,000 units and you want to know whether you should make 1,000,001. Or maybe you make them in thousands, so 1,000,000, 1,000. Whatever the case may be, whatever you already produced and the next level of production. And we usually break it down to a per one unit. The math will oftentimes do this, which is why the definition has just one more unit. One more, and a unit can be a bundle. In case you want to do it that way to make it one unit. But again, it doesn't matter if we haven't started production at all, we've made 0 and we want to know if we want to make 1, or if we made 1,000,000 and we want to make 1 more. The marginal cost, I just described the margin going from one step to the next. The cost is what we're going to look at here. How much is it going to cost you, that one extra unit? It's going to be the change in your total cost. Your total cost for the 1,000,000th unit was whatever it is. The 1,000,001th unit, or 1,000,000th first, the 1,000,000 plus 1 unit, whatever that is going to cost more. Your total cost is going to rise by however much it does. That difference between the two total costs is going to be your marginal cost, and that shows up here in the equation for marginal cost. Our good old friend, the Greek letter delta here, the change in total cost, which is just the new total cost if you make that decision, minus the current total cost. So it could be total cost 2 minus total cost 1. And then you're going to divide that by the quantities. The quantity if you decide to do the next unit minus the quantity right now. So this expands it to what I just said. You have your new total cost, subtract out the old, divide it by your new quantity with the old subtracted out, and you get your marginal cost. Similar to other marginal formulas we've looked at already, just particular this time to the additional cost that you're taking on for that extra unit of production. And here is what it looks like graphically. This graph, it's the big check mark, Nike swoosh, whatever helps you remember it. Like average variable cost and average total cost, it goes down for a while and then it goes up. This is once again capturing the law of diminishing marginal returns. In this case, the law of increasing marginal costs. At the very, very, very beginning, you're going to see your costs. You don't necessarily need to know exactly why this happens, but it does happen in practice, where the more units, the more you produce at any level of production, and this will become a bit more clear when we get into economies of scale, you're being more efficient. You use a giant machine that can make 1 million cars and you make only one. You're not getting the most out of that machine until you actually make 1 million and you're using it to full capacity. And your additional costs for each one, they're going to go down for a while, but then eventually your production capacities are going to be strained, and that additional total cost for each additional unit is going to be higher than at previous units. So marginal costs, they'll kind of fall for a little bit in the beginning, but very early on, they start to rise, and then they never stop rising. As you produce more and more and more, your marginal costs just keep going up and up and up as you strain your productive capacity more and more. So adding it onto this graph, this is what it looks like. And there are a couple things to notice here. Notice we took out average fixed cost. That doesn't really need to be here. From actually most of our analyses, I said we're going to come back to this graph later in the semester. We're going to come back to it a lot, and indeed we will. But when we come back to it, we're usually not going to care about average fixed cost. That's going to become relevant again when we talk about scales of production. The more you and that's also why at this point, average total and average variable costs are closer together than they are here. Your average fixed cost is higher here, but as you produce more, as your quantity goes up, your average fixed cost gets smaller, so the space between these two is eventually going to get really, really small. So the average total cost and average variable cost curve, they're not perfectly parallel, but one, the average total cost curve, is always above the average variable cost curve. Because again, this is both. Everything that goes into the AVC, the average variable cost curve, is in here. Everything that's in the average variable cost curve is in the average total cost curve. But the average total cost curve also has your fixed costs in there. So it's always going to be larger than average variable cost at every single quantity. Average total cost is always, always larger than average variable cost. So this curve is above this one. Average total cost is above average variable cost at every quantity. They have a similar shape, but they're not exactly parallel. Now contrast that to the marginal cost. The marginal cost starts out beneath all the rest of them. And then it cuts through first the average variable cost, then it cuts through the average total cost, and then it just keeps going up after that. All of these points of intersection are important, and they're going to be important for different reasons. But why? Why does it have these different shapes? Well, it's beneath all of these at first. It's going down while these are going down. That's one thing to notice. And it's because all it's doing is it's taking the new total cost minus the old total cost and looking at the difference between the two. And that's all it's doing throughout this entire curve. And it's adding up total costs that, again, with the fixed costs, those fixed costs aren't changing. They're just going down. But the average variable costs, the variable costs are going up with each additional unit. So at the very beginning, marginal cost is going to be beneath all of these because you're not straining your capacity as much, and you're at a point where your marginal costs are falling. But once they peak, the marginal cost just starts rising. If marginal cost doesn't ever stop rising and it rises faster than these two, then it's going to cut through each one. Now, where it intersects these curves, you might notice just by eyeballing it, these aren't drawn to scale, so you can't confirm it, but it cuts through the average variable cost curve at the lowest point. if this is drawn correctly, if it were drawn to scale, this would be, and they're trying to make it look as though it's the lowest point on the average variable cost curve. This point is higher, this point is higher. Every point next to this point of intersection is some tiny amount higher. This is the absolute lowest point. This is what's often referred to as an inflection point or a turning point. This is where your average variable costs start to rise. You're no longer taking advantage of economies of scale. You're at the point now where you're starting to strain your productive capacity more and more and more, and you're starting to have to pay workers overtime. They're part of your variable costs. You're starting to have to rent extra space or whatever you have to do. Given your current level of production capacity, you're having to strain it more and more. So it starts to go up right here, and it starts to go up at the point at which your marginal cost and average variable costs come equal. And when you look at the math that goes into these things, it's beyond the scope of this class to go into it, but you can check for yourself to verify that the minimum point for average variable cost is going to be exactly equal to the marginal cost at that production level. When you haven't reached the minimum yet, it's going to be greater than marginal cost at that production level. And when you're beyond that minimum point for average variable cost, it's also going to be less than marginal cost at that production level. They intersect at that absolute minimum point. Often have to do a little calculus to find that out, which again is beyond the scope of this class, but that is one common thing that comes up in economics a lot at later stages where you have to solve those kinds of formulas, but you don't have to worry about it here. Just know that this is the lowest point for the average variable cost curve is where marginal cost will intersect it. And then same thing here. The average total cost curve meets the marginal cost curve at the point at which your average total costs are as low as possible. When your average total costs are at their absolute lowest possible point, they are equal to marginal costs. When you haven't gotten to that low point yet, your average total costs are higher than your marginal cost. And when you're beyond that lowest point and your average total costs are going up forever, they are below your marginal costs. So this point of intersection, both of these points of intersection are going to be important for different things we're going to look at when studying the firm. And this one is going to come up very often. So it's good to keep in mind that these are important points and that the marginal cost curve cuts through these. Also, for exam purposes, these curves will be unlabeled, and for the exams I'll also put in the average fixed cost curve that goes down here. You're not going to have the labels, but based on their shape and their relationship to each other, you should be able to identify that this one's the average total cost curve, this is the average variable cost curve, and this rapidly rising one that cuts through them both. The only one that intersects all of the curves is going to be the marginal cost curve. And we will get into the long run and the importance of that in the next video.